Greetings and welcome to the tutorial for creating a voxel mesh. Our objectives here are first to understand some mesh settings, then to create a voxel mesh, and finally to refine the settings to improve the mesh. So in NETFABB simulation, we import a part. We indicate that it is a part rather than a support structure. We check the model units, and then we have the part in place. Might want to reposition a little bit, and then the first place we go to is the Mesh Settings dialog. Here we choose the layer-based meshing approach for more direct control of the mesh accuracy. In this meshing approach, we work with settings for coarsening generations and layers per element. Start by setting coarsening generations to 1 and layers per element to 20. Coarsening is the process of combining small mesh elements into larger elements in areas where fine detail is not required, such as on the build plate. Layers per element is the number of powder layers in the thinnest element of the part. The value of 20 here should generate a fairly coarse mesh with a short runtime. Click OK, then click Mesh Preview, and save the project with a suitable name in the right directory. As soon as we click Save, the generation of the mesh begins. The solver evaluates the geometry for thickness in different areas and generates small 3D elements or voxels in areas of detail, and larger voxels where less accuracy is required. When the analysis is done, the results are loaded. To better examine the mesh, we add a clipping plane from the View tab. Press Clipping here, and then we can edit it. Snap the plane to the YZ axis. See how that looks? And we're on the wrong side of the clipping plane, so we click Invert the Normal. Then click Close, and we can get a better view of the inside of the part. Notice that the side walls here have a thickness of 1 element. A rule of thumb in NETFABB simulation is that these should have at least 2 elements. So we're going to refine the mesh. Turn off the clipping plane and go back to the Home tab to Mesh Settings. Change the layers per element value to 10. This should produce a finer mesh. Click OK and then generate a new preview. This mesh is going to take a bit longer to generate because it's more accurate. When we see the results, the curves around the top are a little more detailed and smoother. Let's examine more closely with the clipping plane from the View tab. Choose the same settings. And now we can zoom in and examine the mesh in more detail. We see that the sidewalls now have a thickness of 2 voxels, which is more suitable. This cross-section also clearly shows a unique feature of the NETFABB simulation solver, which is that it can handle hanging nodes or constrained nodes like we see here. As a result, over a very short distance, the mesh can change from small voxels in areas of fine detail to large voxels in areas such as the build plate where lower resolution is acceptable. This feature allows us to keep the number of degrees of freedom very low in the analysis, which results in very fast run times. So, in summary, in this tutorial, we learned to understand voxel mesh settings. We created a voxel mesh, examined it, and adjusted the settings to make a mesh that's more suitable for analysis.